Brad Williams, Frugal Finance. Multiple compounding periods in a year. This is going to be a test. In other words, I'm going to throw a bunch of hypotheticals. They're already solved, but it's a test that it really will put you in a position as to whether you want to continue studying additional finance tools or not. So here we go. Not all interest rates are shown as annual compounding rates. In the business world, it's not uncommon practice to find a non-annual interest rate as follows: 12% per year, compounded monthly, or 12% per year per month. When shown in this form, 12% per year per month is known as the nominal annual interest rate. Unfortunately, the techniques we've used up to now cannot be used directly to solve a finance problem of this type because the interest period per year and compounding period monthly are not the same. To fix this problem, one of two approaches can be used: the period interest rate approach or the effective interest rate approach. We must decide to use the period interest rate approach. We must describe a new term, the period interest rate. Period interest rate is equal to nominal annual interest rate divided by the number of interest periods per year. In other words, our interest rate divided by periods. Using the previous example, we have 12%, 12 months, 1% per month. Now, the interest period and the compound period are the same. $2,000 is invested in an investment that pays 12% per year compounded monthly. We have a nominal interest rate of 12%. We have a period interest rate of 1%. Number of interest periods, 3 years times 12. Got that? Here's this ugly deal for the engineering perspective, which I loathe, by the way. So we have 1 plus 12 divided by 12, and then there's 36 periods. 3 years times 3. You can go 12, you can put in parentheses 12 times 3 if it's easier to see. Here's our factor. This is a compounding factor, and if you don't have a finance book, this is how you compute it. Just don't put your starting number in front of it. And then all you do is multiply. In this case, we wanted $2,000 invested at 12%. In 3 years, it's going to be worth $28.62. That's it. That's it. Now, if you go 1 plus 0.12, and then 3, you just want to put caret 3, you're going to see this is going to be probably 2650 something. So the impact of compounding is surprising. $2,000 deposited into a money market account paying 12% per year compounded semi-annually for 3 years. So you can see right there, we got 2862 for monthly compounding. Look at the difference. You're compounded 12 times a year, or we have 6 compounding periods versus 36. Here is the breakdown. We're going to go $2,000, 1 plus 12. Be sure to divide this by the number of annual compounding right here. And then your total number of compounding periods. So 3 times 2 is 6. Sometimes it's easier just to put 3 times 2 there. Here we have the same thing using Excel. Be sure to recognize that you got to divide this by 2. And then number of periods, total number of periods, compounding, and then your payment is blank. Keep that in mind. We're not looking for a payment. We're looking to future value. Make sure, even though, this is how crazy this is, even though you're figuring out the future value, your payment, your current present value is $2,000. Just remember that. What's the present value? It's what the number is today. You're looking to figure out what that is down the road. Again, we have this compounding, and then you can just multiply this by this to come up with the equivalent. 2,000 deposited in a money market account paying 12% per year compounded quarterly. 2,000 deposited into a money market account paying 12% per year compounded daily. Here we go. You're going to have to do a little more work. Here, this is the simple way to do it. You're just going to substitute your periods. So here we have 365, and then we're going to take the number of years times 365. Notice I said it's sometimes easier to do it this way for notational purposes, or if somebody else is working on this spreadsheet, it's a little easier to identify what's going on here. Here's the nominal annual interest rate. All we're doing is the same thing minus the principal amount. Here's your principal, period interest rate. I just put this $2,000 in there because I probably referenced it above. So all I did is I took C52 times 1.4332, and we're going to come up with 2866. Here is Excel, and then here it is hard-coded traditional. Daily cup of coffee. This is going to shock all you Starbucks fans. You have a habit of drinking a cup of Starbucks coffee, $2 a cup. Well, why don't we put it in reality? How about, oh, I don't know. What do you think it is now? $5 a cup? I don't know. We'll say $5. On the way to work every month for 30 years. If you put the money in the bank for the same period, how much would you have? Or how much will you waste by walking into Starbucks and paying them for a $5 cup of coffee when you can brew it yourself for 90% less? The bottom line here is if you're spending $5 for whatever, a cup of sugar is when you go to Starbucks and you ask for one of these fruit food cocktails, coffee cocktails, you're going to end up spending $127,000, the equivalent, $127,000. Put that into your retirement account or your kid's college fund, and voila. Suppose you make quarterly deposits of $1,000 into a fund that pays interest at 12% compounded monthly. What is the balance at the end of year 3? Notice we took a bit of a curve here. We're saying you make quarterly deposits of $1,000. What is the balance at the end? Well, we looked at this in the previous 2 tutorials, but this is, you make a quarterly deposit. So this is that sort of that geometric format. So we have $1,000. And then this is what is the balance. So this is a one-time deal. So here's our compounding. We have 14,216, and then 14,192 would be quarterly. And then 14,216 would be this 303 monthly compounding. I just wanted to show you 2 different examples. Suppose you make quarterly deposits of $1,000 to a fund that pays interest at 12% compounded monthly. What's the balance at the end of year 3? 14,216, and then this would be quarterly. So this is the number and this is monthly. Got that? And see how easy it is to compute this as opposed to that crazy brain damage in the previous example. Effective annual interest rate. What we're going to do here is we're going to use some Excel tools. Here, again, think about the algebra. So now we're going to try to solve for I. What formula were we using before? I didn't hard code it. So we would probably go up. I'm using just Excel here, but you may want to go up to one of these others, like right here, or you might want to go up here. And if you need to break this down, if there's not a hard coded formula here, right here, what do we got here? I. So I here, so you can solve for I. You can go down here and the effective annual interest rate, 1 plus R divided by CK. Then let's see, the notation is a little bit different, but here's I equals 1 plus R, etc. And then here's just the plug and chug numbers. Understand the logic, okay? I don't want to skip on trying to explain what this is. It's pretty self-explanatory. You're trying to find I instead of here, which would have been P or what have you. So our effective annual interest rate, what is this cube? Because the question is, if we look at this final hard-coded number, I is equal 1 plus 0.01 cubed minus 1. Why is that cubed? And why is it 0.01? The answer is we are looking for the annual interest rates. We take 12 periods. If we go 12 divided by whatever that interest rate is, what was it, 10%? 10 divided by 12 is 1. And then how many compounding periods? 12% compounded monthly. Oh, that's where it was, duh. All right, this is, I'm trying to do too many things at once here. So this is compounded monthly. That's why we want 12 divided by 0.12. Well, we know with 12 periods, it's 0.01. And then the number of periods is 12. But then if you look, we're going to look here and we have 1 plus 0.0303 as opposed to 0.01. Why? What's 4 divided by 0.12? Why is this 0.0303? What is 12 divided by 4? It's going to be 0.0303. Why? Well, we're asking for quarterly. So you have to go quarterly. And then why is this cubed? Because this breaks down that 12% to 3.03. Got that? I is equal 1 plus 0.01 cubed, so 3.03. And then here, how many periods are there? 4. 4. Remember, up here we use 36. Here we used quarterly. So we're going to use this in. That is our effective annual rate. Effective interest rate per quarter. We're going to do the same thing. We have the effective rate, the nominal rate. Go back above if you need to read this over again or the previous. So here we're just going to use the effect formula. Why brute force this when we can use the tools available? And then we have our nominal, which is nominal, another tool, an introductory to another tool. And then interest rate per quarter, we've done this. And then if you need to break it down, here is interest rate per quarter, 9% divided by 4 equals 0.0225. Number, 4 periods, and then our 10 grand. Then if you want some other information, just go through here. You need $1,800 per month for 20 years on a $250,000 investment. What rate do you need to earn this? Great question. $1,800, which is payments 060618 divided by 12, 2012. So I cheated. I gave you the answer ahead of time. But if you just have this information, you're going to use this rate function. What do we have? What do we know? We know this is $1,800 per month. So we know we have 12 times 20 are the, go through rate, number of periods, 12 times 20. What do we need? Remember, this is the number you need, 1,800. What is given? Well, we only have 250 grand, so that's going to be your present value. Then we're going to have future value. No, this is going to compute a monthly number because that's the number of periods. Then we're going to multiply that times 12. It's going to give you, a monthly interest rate, and all we're going to do is multiply that times 12. So we need a rate of 6.0618 to get $1,800 a month. How far can you get on $1,800 a month in this era where a cup of coffee is $5? A gallon of gasoline in the US is $5. That's not going to get you very far. If you were to take this up to what, 10 grand? We took, what was the number I need? 250. That's why you don't hard code this information, because if you want to make changes, you have to do it individually. You can put 250 up here, whatever number you want. Then every time there's a 250, you can just reference this. Okay, that's called hard coding, and we're not hard coding here. Then you can go here and you can do the same thing with each one of these numbers. I'm just putting 250 in here now. And then 1,012, so 0620 times 12 is 462. 620 times 12 minus 1,000. This is another question. Deposit 1,000 per month, earn 6% compounded monthly for 20 years. It will be worth 462,041. That's almost a future value deal. If you change this to 6.0618, they should reconcile. But here, if we change this to go 10 grand, oops, let's say you're going to need $1 million. 1, 2, 3, 4, 5, 6, F9. So there you go. You need 7,200. Oops, something screwed up there. Oh, the reason being that 1,800 is fixed and that can't be fixed. Now, what I did is this was hard-coded. This 1,800 was hard-coded, and all I did was reference the 1,800 above, and this formula is going to be wrong here. If I put $1 million, 1, 2, 3, 4, 5, 6, that may be, is that 10 million? Yeah, that may be too many zeros. F9. So you need $7,200. You need $7,200 per month for 20 years on 200. So $1 million. You put $1 million, earning 6.618%. You can take $7,200 a month for 20 years. Got that? And lastly, and this is something I always forget, you want to copy this formula over. I used to always just copy and paste this over. So I'd copy and paste. But there's a formula you can use. It's called formula text. All you do is equal formula text, and then you reference the cell, and it copies it over. I always forget about formula text until I get to the point where I'm frustrated, and then I will look in my references, and I just did it. I went back, and I have references just to give you an idea of how many formulas I use. Here is all of the formulas I use, and it's, what is it? There's 673 rows, and there's a lot of notations. And there's 1,500 different functions within Excel. And I use, I don't know how many, there's probably 400 that I reference at some point in time. And I can't remember them all. That's why I take meticulous notes, because there's just so much information within Excel. And that's the problem with Excel, is a lot of this stuff is dated. And they could upgrade it, but they won't. They never will. It's just too big of a problem. So it's up to you in order to either learn this stuff or know where to find it. And I'm going to end that conversation there on this topic. In the end, this is a number you can manipulate. So you need whatever number this is, 1,800. But here I said you wanted 7,200. And then again, you could text this out if you want. In other words, I could reference the 7,200 in this text. So this would say you need whatever that changing number is. I'm going to change this back to 250. 1, 2, 3, F9. And the story ends there. Brad Williams. Frugal Finance, a whole lot more to come. Be patient, practice, practice, practice.